Now see here the next chapter, that is current electricity. We have studies about the electrostatics, where we were studying about the charges which were at rest. Now here in the current electricity, we are going to deal with the charges which are in motion. So first one is here, that is electric current. So what do you mean by electric current actually? That is the first part of this chapter is electric current. The flow of charge in a definite direction constitute the electric current. So when the charge flows in a definite direction, they constitute electric current, and the time rate of flow of charge through any cross section of a conductor is the measure of current. Now we can write electric current I is equal to Q upon T. Suppose you have taken any conductor like this, or any area you have taken here, in this way cross section area of a conductor, and Q plus charges are flowing to this side and Q negative charges are flowing to this side. Now, so the net charge we will be getting here Q plus minus Q minus, and this net charge Q is proportional to T provided current is steady. So we can write here I is equal to Q upon T, where Q is measured, Q we can take as 1 coulomb and time we can take is equal to 1 second. So we can write here I is equal to 1 coulomb upon 1 second, that is equal to 1 ampere. So ampere is the SI unit of electric current. Suppose current is not steady, then how we will define the current flowing through the conductor? Suppose if the current is not steady, then definition of the current is given like that. Suppose this is a cross section of a conductor, and just to imagine an area which is perpendicular to the flow of the current, normal to the direction of the flow of current. Suppose through this area of cross section, charges are flowing in the time interval delta t is delta q. So delta q charge is flowing through this area which is held normal to the direction of flow of current in time interval delta t. Then we can define I is equal to limit delta t tends to 0 delta q upon delta t, and that can be written dq upon dt. It means in this case electric current is the first derivative of the charge with respect to time here. So if the now we can understand the direction of the current in the circuit. So see here, if you have taken like a battery and connected to the any conductor, suppose I have taken here conductor, this is a part of the conductor which is connected to a battery here or cell, anything, this is plus, this is minus. When the here it is connected to the battery, a potential difference is maintained across the ends of the conductor, and due to this potential difference actually here electrons start moving, and electrons move from this side negative to positive, but the direction of current, that is a conventional direction of current, is taken positive to negative. If this end is A and this end is B, so conventional direction of current is from A to B, whereas electrons are moving from B to A. So the conventional direction of current is actually the direction of the flow of the positive charges. Electric current is a scalar quantity because it can be added or subtracted algebraically. Despite of a direction, it is assumed to be a scalar quantity. So this is about electric current.